We will conduct experiment on Zener diode, reverse bias characteristics of a Zener diode. Here you should connect the positive terminal of the power supply to 1 kilo ohm resistor, other end of 1 kilo ohm resistor to cathode of Zener diode, and anode of Zener diode to milliammeter positive terminal, and negative terminal of the milliammeter back to negative terminal of the power supply, and 1 voltmeter across the Zener diode in order to measure the voltage across the Zener diode. This multimeter I am making as milliammeter, so I am keeping this milliammeter in 20 milliamps, and this multimeter I am making it as voltmeter. I am keeping this in 20 volts DC, and according to the circuit diagram, the positive terminal of the power supply, it is connected to 1 kilo ohm resistor. From 1 kilo ohm resistor to Zener diode, this is Zener diode, blue strip is cathode and red one is anode. So I am connecting blue strip to one end of resistor and other end of resistor on the breadboard. Okay. And this voltmeter I am connecting across the Zener diode, positive to cathode and negative of the voltmeter to anode. And how to connect the milliammeter? The positive terminal of the milliammeter, this is milliammeter, positive terminal of the milliammeter to anode, and the negative terminal of the milliammeter to power supply. This is power supply, negative terminal of the milliammeter to power supply. So this is as it is in a circuit diagram. How it is drawn, I have done the connection in that manner. Here I have taken a 9 volts Zener diode. So before turning on the power supply, current knob should be in maximum position and voltage knob should be in minimum position. And now you turn on the power supply. So adjust your voltage to 2 volts. In steps of 2 I am doing. Volts. Let us see the current. Voltage is 1.50 and current is 0. Current is 0. Voltage is 1.49. Power supply voltage is 2 volts. Voltmeter reading is 1.49 volts and current is 0. Let us adjust the power supply voltage to 4 volts and the voltmeter reading is 3.43 and current is still 0. So power supply voltage is 4 volts, the voltmeter reading is 3.42 volts and current is 0. Now let us adjust to 6 volts. Power supply voltage is 6 volts and voltmeter reading is 5.48 and current is still 0. So 6 power supply voltage, 5.48 voltmeter reading and 0. Now we will adjust power supply voltage to 8 volts and multimeter reading is 7.53 and current is 0.01. So power supply 8 volts, 7.53 voltmeter reading. This is voltage across Zener diode and current is 0.01. Now in after 8 you increase in steps of 0.5. Now I will make 8.5. 8.5. Voltage is 7.89 and current is 0.01. 8.5, 7.89, 0.01. Now I will make it to 9 volts. 9 volts and voltage is 8.42. Current is still 0.01. 8.42 volts across Zener diode and current is 0.01. Now I will make it 9.5 volts. 9.5 volts. Voltage is 8.77. Current started flowing now. It is 0.15. 9.5, 8.77 voltage across Zener diode. Current is increased. You check these two reading. Earlier it was 0. Now it is becoming 0.15 milliamps. Now I will make it 10 volts. 10 volts. Voltage is 8 and current is 0.87. Voltage it is showing 8.8 and current is 0.86. You check the difference. Again current is further increased. Now I will make it 10.5. 10.5. Voltage is 8.82 and current is 1.3. For 10.5 volts, voltage is almost remaining constant on 8 volts, but current is increased further. It is high current now, 0.8 to 1.3. Let us take one more reading, 11 volts. 11 volts and voltage is remaining same, 8.8, and current is further increased to 2.03. For 11 volts, voltage is almost remaining on 8 volts and current is increased more, 2.03. Let us take last reading, 12 volts. 12 volts, the voltage is remaining same, 8.8, and current is 2.8. So from these readings you can understand, initially as we increase the supply voltage, the Zener voltage also increases. After Zener voltage, this is 9 volts Zener diode, you can check here from 9 volts onwards current started increasing. It means that the Zener diode conducts after 9 volts. Therefore it is a 9 volts Zener diode. If you see the characteristics curve, so from 0 volts to 9 volts current is almost 0, and when it reaches 9 volts the current increases rapidly. So in this way current starts flowing after the Zener voltage. So this is reverse bias characteristics of a Zener diode experiment.